In this problem, we're asked to find the solutions of the equation sine of 2x minus pi over 3 is equal to 1/2. In order to solve for this, we are looking for an angle that we plug into sine and we get 1/2. Therefore, if we do a substitution and let theta be equal to 2x minus pi over 3, we are looking for general solutions of sine of theta is equal to 1/2. That would occur in quadrant 1 when theta is equal to 30 degrees or pi over 6, and in quadrant 2 where theta is equal to 5 pi over 6. And then we would add on the period of our sine function, where n is any integer. Now we can solve for 2x minus pi over 3 is equal to those general solutions. We will examine the first one. In order to solve for this one, I would have to add pi over 3 to both sides. Pi over 6 plus pi over 3 is pi over 6 plus 2 pi over 6, which is 3 pi over 6, or equivalently pi over 2. Therefore, 2 times x is equal to pi over 2 plus 2n pi. Dividing everything by 2, we would get pi over 4 plus n pi. We would recognize that pi is indeed the period of the sine of 2x minus pi over 3. Likewise, we can solve the other general solution, where 2x minus pi over 3 is equal to 5 pi over 6 plus 2n pi. Again, adding pi over 3 to both sides, we would get 5 pi over 6 plus 2 pi over 6, which is 7 pi over 6. So 2x is equal to 7 pi over 6 plus 2n pi. Dividing everything by 2, we would get the general solution 7 pi over 12 plus n pi. In our next problem, we are asked to find the solution to 2 cosine t plus 1. In order to solve this problem, we would isolate cosine of t by subtracting 1 and dividing by 2. Therefore, cosine of t is equal to a negative 1/2. Therefore, we know that we are looking for either quadrant 2 angles or quadrant 3 angles that have a reference angle that produces cosine of that angle to be equal to 1/2. We know that that is at 60 degrees or pi over 3. Therefore, our quadrant 2 angle would be given by 2 pi over 3, and then adding on the period of cosine. Our second value would be in quadrant 3, and our quadrant 3 angle with the reference angle of pi over 3 is 4 pi over 3, adding on the period of cosine. In our next problem, we are asked to find the solutions of the tangent squared x is equal to 1. We would recognize this in a couple of different ways. If we had the equation x squared is equal to 1, when we took the square root of both sides, x could either be a positive 1 or it could be a negative 1. Therefore, if we take that, we would see that in this case, either the tangent of x is equal to 1 or the tangent of x is equal to a negative 1. Another way we can see that we have two sets of general solutions is we could bring the 1 over to both sides. So we'd have tangent squared of x minus 1 is equal to 0. We could factor this down as a tangent of x plus 1 times a tangent of x minus 1 equaling 0. Therefore, we'd have tangent squared minus tangent plus tangent, which cancels to make 0, minus 1. Again, therefore, tangent of x plus 1 was 0, giving us this part of the equation, and tangent of x minus 1 giving us this equation. We are now ready to find the general solutions. Places where tangent of x is equal to 1 in quadrant 1 would be at 45 degrees where cosine is equal to sine. Therefore, we would have x is equal to the square root of,